Hi there, and welcome to reInvent. I'm looking out here. I'm guessing a lot of you are builders or security professionals, or maybe you actually are curious about bots, or maybe you even have a problem with bots and you're hoping that you'll learn something from this talk, so I hope you will. Our talk is going to be about how you can control the bots and prevent account fraud using AWS WAF. My name is Chris Atwellid. I'm the general manager for AWS WAF. Over here, we have Nitin Saxena, who is my partner in crime, who will be going deep in just a little bit. So first of all, let's go over what we're going to talk about today. We're going to let you know a little bit about what the capabilities of AWS WAF are. We're going to focus around the bot and fraud technologies. We're going to dive deep into the bot and fraud technologies and how they work, how you'll be able to put them to use in your website and application. And lastly, we're going to go through some real-life scenarios around instances where we've been able to help customers using the technology. So first, what is AWS WAF? So AWS WAF is a multi-layered security execution engine that evaluates requests. It protects you against common internet threats like cross-site scripting, SQL injection, application vulnerabilities. In a pinch, it will serve as a zero-day mitigation. It is able to implement policy like geo-blocking if you don't want to serve to certain areas. And it also does traffic shaping so that it can protect you against denial of service attacks. And of course, it does bot control and fraud. So this is a normal data flow for WAF. You can see that a user or a malicious actor is submitting a request. AWS WAF is going to be evaluating that request with either Amazon managed rules, so those are rules that we keep up to date and we make sure that they're going to protect you against common threats, or your own rules. Those are going to be served by our front door services like Amazon CloudFront, the application load balancer, Amazon API Gateway, AppSync, and Amazon Cognito. The thing about this is it's very easy for you to implement into your application. So if you want to have protection, even if it's an on-prem application, you can pretty easily throw a CloudFront distribution in front of that, put WAF onto it, and then you're going to have a pretty good level of protection against basic internet threats. So it's good for that. It's also really great for AWS workloads. It's a managed service, so all the resources that you need are deployed automatically. You don't need to do very much with it at all. The focus of this session is going to be around bots. So what is a bot? Actually, I bet most of you are probably running bots of some kind. We use them just around our health monitoring, right? We want to make sure that the service is running, so we have lots of queries going out. But basically, it's around a service that's just making repeated queries without human intervention to a web service or application. There are good bots and bad bots. They've both been around since the beginning of the internet. The first bots were around exploring the internet and making sure it could get indexed so that people would be able to find things. People would use them to make sure that their site was up. Good bots are easy to spot because they don't try to hide. They have a user agent that does not change. They respect your robots.txt. For those of you who don't know, that will be telling the bot where it can explore, where it can't explore, the rates that it's allowed to be able to operate at, and so forth. It will try to keep your site up. It's designed for good, and it provides a lot of really great utility for you as both an operations point of view and from a customer point of view. Malicious bots, on the other hand, have also existed since the beginning of the internet. They put your business at operational risk, business risk, security risk, financial risk. They absolutely need to be controlled. The first ones were actually denial of service bots. They would just try to overload a site and try to make it crumble to the ground. Later, they evolved into more interesting bots. So bots that would try to find security vulnerabilities, bots that would try to take data from your application and be able to publish it maybe as an aggregator, possibly in giving you a competitive disadvantage. Sometimes they're used for very specific purposes, so they may be targeted at your business. An example of that would be a bot that crawls sites looking for betting odds and then performs bet arbitrage, as an example for those of us who are here in Vegas. One of the effects that you don't think about too much with bots, but it's really important, is that it obscures all of your web metrics. So you think about, you're trying to find out, is your marketing campaign working? Right? Are you bringing more people onto your site? What's the user journey that people are following on the site? Are they able to do workflow completion? Are they able to fulfill their orders? Are they able to quickly find what it is that they're looking for? When you have a lot of bot traffic, it makes it very, very difficult to see between the lines around what's real and what's not. It makes it harder to improve your site. You can see there are a lot of other risks around just reputational risks, like bots that will do fake reviews. They'll manipulate SEO. They'll do account fraud. They'll actually log in as users and perform actions ranging from those kind of review things to actually stealing user data and stealing your data. Lastly, it just costs a lot. One of the surprising things, again, you don't think about until you're starting to poke around at it, is that we find, anyway, that nearly half the traffic that a site might get if they're not employing some sort of control mechanism, almost half the traffic is going to be bots. And in fact, some customers, if they're doing a one-time sale, that cost could be up to like 95% of their traffic is coming out of bots trying to perform some action. So it's something that you really want to take control over because it can have a material impact to your business. So with that, I'm going to turn it over to Nitin to do a deep dive in our bot control. Thank you, Nitin.
All right. Thanks, Chris. All right, good afternoon, everyone, and welcome to re:Invent. After the introduction, I know you are eager to learn about how AWS WAF works to protect your applications and prevent risk that's associated with bots and fraudulent activities. So let's dive right in. I'm going to start with a architectural overview of AWS WAF. So we're going to see how a request comes and how it's handled. We're going to start with a application which is behind a protected service, such as CloudFront, ALB, API Gateway. When a normal user or a malicious actor, at this point we don't know what is what, any request that comes into a protected service, when you have AWS WAF configured to protect that service, the request is inspected by the AWS WAF rule engine. As Chris alluded to earlier, that it has a rule engine in which you can place different kind of rules. Some are managed rules, custom rules. We're going to go more over quite a few of them. If you have configured your protected resource to be protected against bots and fraud, the request is further inspected by bot and fraud detection services, which are also running behind the AWS WAF rule engine. And depending upon the decision that is sent back, either the request is considered safe and it is allowed to proceed to the application origin, or the request can be stopped from proceeding to your application. When we started designing bot and fraud control, we realized one thing, that this is an evolving landscape. This is constantly changing. The bot operators are changing tactics, trying to fly under the radar, and trying to evade detection. So we decided to go the route of making these services available as Amazon Managed Rule Groups, or we call them AMRs. So I'm going to use the term AMR quite a bit in this context. AMRs are packaged rules, set of rules. So think about, it's a rule group, which is prepackaged. It contains a set of rules. And these rules can be customized to a degree. And what it does that it allows us to keep adding new rules into the AMR as bot and fraud vendor operators evolve. So once you add an Amazon managed rule group, you can take advantage of new innovations coming in without doing anything, and we do all the heavy lifting on that front. So I'm going to draw your attention to 3 AMRs and 4 use cases. The first AMR I'm going to talk about is AWS Managed Rules Bot Control. That's number 1 over there. And this AMR supports 2 use cases, common bots and targeted bots. Common bots is our way of helping you manage good, verifiable bots. And there are reasons why you want to manage them. They may be good, they may be all verified, search engine bots, advertising bots, monitoring bots, but you also want to manage them, like how much impact you want to take on your website or infrastructure from those bots. And sometimes even malicious bots also pose as good bots. They will try to use the same user agents. And so we want to verify them, and we want to make sure that a bot comes in, it is what it says it is. So that's common bots. Targeted bots, which is also part of the same AMR, but at a different inspection level, and we're going to talk about inspection level a bit later, is targeted towards managing, controlling evasive, and potentially malicious bots. So these are the bots that try to emulate human behavior, try to evade detection, try to evolve and change their tactics, fly under your rate limits, try to figure out what the rate limits are. So that's targeted bots. The second AMR I'm going to talk about is the AWS Managed ATP rule set. This is geared towards protecting against account takeover attacks. And the fourth one I'm going to talk about is the last one here is the account creation fraud prevention. And the corresponding AMR is AWS Managed Rules, ACFP rule set, which is designed to prevent fake account creation. So we will go over these topics. So let's start with some configuration fundamentals. The first concept is a web access control list, or we fondly call it WebACL. WebACL gives you fine-grained control over all the requests, and it gives you control over how you want to inspect them, how do you want to process them. So you start by adding your protected resource into the WebACL. Now you could create a new WebACL, or you could take an existing WebACL and have a resource there. So what it is telling the WebACL is that I want this resource to be protected. In order to start with bots and fraud, you would add one of the bots and or fraud AMRs. The bots and fraud, the AMRs have 2 kinds of configurations. The first kind of configuration is the rule group configuration. The rule group configuration applies to all the rules within the rule group. And the second level of configuration is the action that you want to take for each rule. So each rule comes with a set of actions, and you can change those actions depending upon what rule, how do you want AWS WAF to process the request. Lastly, you can also add scope down statements. Let's say you want to have bots and fraud services look at only a subset of your URIs. So you can create scope downs to just enable that AMR to look at only those specific requests. Then in the same WebACL, custom rules can be created. One of the concepts I'm going to talk about here is labels. Labels are like tags. So when AWS WAF processes a request, it tags the request stream with a string, which we call the label. And the label can be used to fine-tune detections, and it can be used to fine-tune how do you want to process the request. You can also add custom rules such as matching on path, URI, just based upon regular expressions. You can add rate-based rules there. You can add custom responses. For instance, you want to send a 403 back in a certain situation, and you can add a rule, and it will do that. Let's go into common bots. As I mentioned earlier, the common bot rule sets are designed for managing good bots. To get started with it, you take the bot control AMR, you add it to the WebACL, and this is where the inspection level comes into play, where you select the inspection level as common. Once you do that, these are all the rules within the common bot category that become available to you. We know that you have complex business requirements. You may want to allow a certain kind of bots. You may want to disallow certain kind of bots. You may want to rate limit certain kind of bots. For example, you may want to allow search engine bots, but you may want to disallow link checker or monitoring or scraping bots, right? What we have done is that we have divided bots by a category, and this is where a lot of Amazon experience of battling bots on our retail side comes into play as well. We have taken a lot of signals and intelligence from our experience for handling bots, categorized them into a set of rules, and created these rules, which we are again evolving and changing over time as these categories evolve, new things show up on our radar. And you can take advantage of all this while we are doing the heavy lifting for that. So the next thing is the rule actions. Each rule comes with 5 choices of rule actions: allow, block, count, capture, or challenge. So this is where the second part of the configuration comes into play, which is you take a rule and say category advertising, the default action is block, but I want to change it to allow. One thing I want to call out here is this mode called count. Allow is allow, block is block, capture will throw a capture, challenge will throw a silent challenge. The count is an interesting one, so I'm going to call attention to this. When AWS WAF sets a rule in count mode, it is going to count the number of requests and also create labels for those requests as it counts the request. So this is a very good mechanism when you start playing with AWS WAF and especially bot control. You're not sure what kind of traffic we are getting, what traffic we want to allow, what traffic we want to rate limit. So our recommendation is to always set, when you are trying out bot control as a fresh start, you want to set the rule action to count. This will give you the counts of each category of bots and also will give you the labels using which you can start fine-tuning that. One example of how you can use the label is by rate limiting. Let's say you want to allow search engine bots on your website, but not more than a specific rate, because you don't want to pay the added infrastructure costs that are associated with search engine and scraping. To do so, you can use the AMR and set the search engine category in count mode, which will give you the count and also give you the names of the bots that are coming in. And you can create a custom rule. In this example, we are showing a rate-based rule. And this rate-based rule is the limit is 1,000, and the label, which is just a label string, that label will be replaced by the actual search engine bot, which the name will be as part of the label. And this kind of configuration will allow that particular search engine bot to come in only 1,000 times in a 5-minute window, thereby helping you manage bots. So recapping common bots, you don't need any code or any integration to start using common bots. It's very easy to start. You add the resource to a new or an existing web that you want to protect, and you can start managing self-identifying bots on your website. Like I said, we use multiple techniques. We use signals and intelligence that we have generated over the years to detect and classify those bots, as well as we use techniques such as looking up the published IP ranges, reverse DNS information. So all of that is kind of packaged into the rule group. There is no extra configuration required for us to verify the bots. Anything that is not verifiable, for instance, a bot comes in and says, I am so-and-so bot, and when we look at his signature, when we look at it, other attributes, we deem that, no, this is pretending to be that bot, but it is not exactly that bot. The default action is block for anything that we are not able to verify. Our customers tell us that this rule group has very low false positives, so you can use it with quite a bit of confidence. So how does, now I'm going to go back to the architecture diagram, a slightly simplified version of it, and explain the request flow. And I am going to keep coming back to this architecture because to tie up quite a few things as we proceed through this presentation. A request comes in. It's configured for bot and for protection. It's inspected by the rule engine. It's inspected by the bots and fraud service, checks the signature, makes a decision, and you can allow the request, you can rate limit the request, or you can stop the request based upon rule actions, labels, and custom scripts that you could write using other things as well. Now let's talk about targeted bots. These are bots which will evade detection, they will try to emulate human behavior, and in many cases, they have financial incentives. So how do we detect these bots? They are constantly changing their techniques, they're evolving. And the moment you find a signature, find an IP address, find a rate, they're going to go right past it within minutes sometimes. So when we were thinking about targeted bots, we had quite a few decisions to make as to what is our methodology in finding and detecting these bots. So what are our strategies? First thing we want to do is to raise the cost for them, because many times they have financial incentives. They are scraping something, they are buying tickets, they are hoarding inventory, and thereby causing financial impact. And maybe financial impact to you, financial gain to somebody else. To do that, we force them to execute a proof of work. And we will talk about proof of work and silent challenges in more detail. Proof of work is a cryptographic technique in which a server tells a client to run a particular script and solve a problem. And if the problem is solved, we know that this is a valid client. Second, we want to identify the clients that are connecting to the application. So now think about how requests come into your application. They're coming from a lot of IP addresses. But behind those IP addresses, there are a large number of clients. They could be sharing an IP address. So IP address is really a bad attribute to look at bot traffic. What we want to do is we want to look at a unique client. So we do two things. As the proof of work is run, we collect client telemetry and generate a unique ID. And this unique ID is, using the unique ID, we are able to track a specific client globally, anywhere. And we use the telemetry that is collected to make determinations about what kind of client is connecting and what's the posture of the client that is connected to your application. Lastly, there is a lot about data science and machine learning. Most of our techniques to detect targeted bots are deep-rooted in statistical analysis and machine learning. Few concepts that we briefly touched upon just now. The first one is client challenge and fingerprinting, and the second is AWS WAF token. These two are really important for targeted bots. So what is the cheapest, fastest way for a bot operator? They write a script, they copy the script to hundreds, thousands of nodes, and they launch an attack. And scripts don't cost a whole lot. They run pretty fast. The infrastructure cost that is associated with the scripting is fairly low, but the cost that your applications and websites will incur can be quite high because you are handling all those requests. So here comes in a silent challenge. Client comes into AWS WAF, and this is a simplified diagram to show the flow. And AWS WAF redirects the client to a silent challenge and tells the client to solve a particular proof of work. This proof of work is a computational proof of work in which the client has to perform some action. And in order to perform this action, the scripts don't work for two reasons. Number one, it's a redirect. Number two, the scripts will require JavaScript to be enabled or some sort of integration which could be native to an app, iOS app or an Android app to actually solve that cryptographic challenge. So we are now forcing the client from script to a simulated browser or a automated browser, and the cost difference between running a script versus running Node.js or running Selenium or Puppeteer could be anywhere from 100 to 1000x for the bot operator. Very, very effective in rooting out the script kiddies. So client presents a solution. AWS WAF validates the solution and presents a token to the client. This token is sent back for every subsequent request. And using this token, AWS WAF knows that the challenge was solved and or not solved because that fact is also embedded within the token. As part of running the script on the client side, we also collect a number of attributes. We collect details from the browser or the client, such as their GPU capabilities, canvas fingerprints, browser plugins, screen sizes. Are there any inconsistencies in there? Timestamps on when the challenge was solved. How long did it take to solve the challenge? Human interactions, movement of mouse and clicks. And we take all those attributes and encode these attributes into what we call AWS WAF token, which can be sent back to AWS WAF either as a cookie or as a special request header. This allows us to identify unique clients, and this is encrypted and tamper-proof. We also know that your application environments are complex, and there are limits to, and there are constraints on your end on how you can integrate such a solution. So we have provided some different options to acquire a token and to run a proof of work on the client side. The first one is a challenge action, typically very useful for browser workloads. So if you have web workloads, your clients are going to be normal browsers. The challenge, the redirect, and the proof of work has visibly no impact on a real user, but it raises the cost by an orders of magnitude for bot operators. We recognize that a redirect is not a situation where if you have a post workflow or you have a API workload, in those situations we have an option to an SDK which emulates the same thing, but it does it a little differently. It directly goes to AWS WAF and acquires the token and proves who it is. So we have an SDK. And then we have CAPTCHA 2 flavors. One is a web redirect, and the other one is embedded using a JavaScript API for single page applications or iframes. So as you integrate with targeted bots, you want to think about what is the best option and use the best option for your different workloads and applications to help AWS WAF acquire token and understand the clients. CAPTCHA can be invoked by a rule action. So you saw the rules and the rule actions drop down in which CAPTCHA was one of the options. If you take any rule and set CAPTCHA as an option, it will invoke a CAPTCHA redirect. Single-page applications can use our JavaScript API to embed the CAPTCHA. CAPTCHA also runs the proof of work and the client-side telemetry collection. So everything that is happening on the behind the scenes with the silent challenge is also happening with AWS WAF CAPTCHA. And you can configure how long you want a token that is acquired by running a CAPTCHA can be valid. We talked about the bot control AMR and the two inspection levels, common and targeted. So common was for the good bots and verifiable bots. The targeted inspection level is what you will choose if you want to protect your application against evasive bots. There's an option here to use machine learning. It is enabled by default. When this option is enabled, it allows AWS WAF to capture website traffic statistics and run them through our ML models and provide detections for the level of confidence of what we believe that this request is coming from a bot or from a human. This is optional. If you do not want AWS WAF to use your website traffic statistics and run them through machine learning, this option can be turned off, but it is enabled by default. When you set the inspection level to targeted, these are all the rules from targeted bots that become available. The first rule is a challenge, pass or fail. This rule, the default action for this rule is challenge. If this rule is enabled, it will let a few requests come in from every IP address, because at this point we don't know what the client is. And if the client hasn't yet acquired a token by any other mean, at that time, AWS WAF will force a token acquisition. And if the token acquisition fails, then it blocks that request right there. So any subsequent requests coming from those IP addresses are going to get blocked. Second, we look for volumetric anomalies. So volumetric anomalies they work like rate limiting, but they are a bit more sophisticated than rate limiting. In rate limiting, you specify how many requests, what time window I want. But what we do here for bot control is we do this dynamically. So as clients are coming into your application, and since we are able to track both IP addresses and individual clients using tokens behind those IP addresses, we establish traffic baselines. Right? What are the normal ranges of traffic? And when we see clients coming in that exceed those thresholds, we start issuing block at that point. And these baselines could change during time of the day. And as the traffic patterns change during the day, during the week, during the month on the website, our baselines are continuously recalculated across your entire client base. And at any point of time, any anomalies, meaning that if any bot operator is trying to launch a DDoS attack or they're coming in higher than rate, volumetric session blocks them. We collect signals that we talked about, like canvas fingerprints, plugins. Based upon that, we can look at whether this traffic is coming from an automated browser, or there is some inconsistency about the browser that is behind that particular request. And if we detect any such things, we can block, or the default action for these ones is actually CAPTCHA. Tokens cannot be tempered. They're encrypted, but they certainly can be reused because they're a client-side entity. So there's nothing preventing anybody from opening a browser, making a request, acquiring a token, then copying the token from the developer console and copying it to 100 scripts. But when they do that, two things can happen. One, we will start to see a lot of requests coming from the same token. So that can trigger the volumetric rule. The second thing will happen is we may see different IP addresses associated with our token. Now, that's a valid scenario. Let's say you go to a website on your phones right now and you walk out of this hall and now you're connected to 5G network instead of the Wi-Fi, your IP address is changing. But we allow a same number of IP addresses changes, but if we see that these IP address changes are more than a normal scenario, in that case, we can block them. And the way we determine that what are the thresholds for that is by doing extensive data research on what are the normal patterns and how many times and what is the 90th percentile and what is the 99th percentile of people changing IP addresses. So a lot of data science goes back into determining the thresholds. And lastly, we run your traffic through machine learning and use behavioral analysis. The way we do it is we look for, the rules are called coordinated activity. And the coordinated activity is looking at the pattern, not the rate of the requests, but when a normal user interacts with your site, they're coming in and clicking here or clicking there, but when bots come in, they follow a certain pattern. And the pattern generally differs from a normal user, and the machine learning model discern the difference between a normal user pattern and the patterns created by the bots. In targeted bots, you can also customize the rule actions for each one of the rules. So in this request flow, this is the same diagram that you saw earlier, but I'm going to introduce a couple of new things here. First thing is when a request comes in, we issue redirect to a silent challenge or a captcha. When this is solved, the request comes back in, inspected by the bot for detection services. Bunch of rules are run. The result is emitted back, and based upon the actions, labels, you can make a determination to rate limit, block, or allow the requests. Let's move to AWS WAF fraud control. The first thing we are going to talk about is account takeover prevention. Our customers tell us that a majority of brute force credential stuffing attacks happen via botnets. So there is a good overlap between account takeover prevention and the bot control. And this rule group is designed to prevent bot activity on a login pages and prevent attacks such as credential stuffing and brute force. There are two parts to account takeover prevention, or how we call it ATP. The rule group configuration looks for requests and responses. So first part is request inspection. And in request inspection, you tell us where are the login fields and how are they situated. And in response inspection, you tell us what is a valid response versus what's not a valid response. So a successful login versus a failed login. And that could be a status code or a header or body. And both when the request comes in, AWS WAF is looking at both the incoming request as well as outgoing responses from the origin to determine whether these are normal users or somebody is trying to do something malicious with and doing brute force or credential stuffing attacks. Since we do need to inspect usernames and passwords, these rules are only available when AWS WAF can inspect the credentials. If you are using some Cognito or other IDP, in that situation, since AWS WAF is not going to see the user ID and password, account takeover prevention cannot be used. Two more things I want to call out here. One is stolen credentials. We maintain a vast database of stolen credentials, which we constantly keep up to date. And if a request matches any stolen credentials, then it is automatically flagged and blocked. The second thing I want to call attention to is response inspection. So think about response inspection capability as a safe. So let's say a client comes in, they are not using stolen credentials, but the response is failure multiple times. That tells us that somebody is trying to traverse user IDs, passwords, trying different combinations. And after a certain number of failed requests, we block that particular IP address for a period, thereby dramatically slowing down the attack. And when they see the attack slowing down to that degree, the credential stuffing is just not a valid technique at that point. Account creation fraud prevention works very similarly to account takeover prevention, but this is designed to prevent bot activity on sign-up pages instead of login pages. And the goal here is to prevent fake accounts. Once again, there is request inspection and response inspection. In the request inspection, you are telling us how to parse your form. And in response inspection, you are telling us how to parse successful or failed account creation attempts. When you enable account creation fraud prevention, a number of rules become available, and like we have seen, the rule actions for each one of those rules can be configured. I want to call out attention to 3 things. The first is the rules are designed to automatically challenge bot activity on sign-up pages. The number 2, we use reputational scores such as reputations of IP addresses or email addresses associated with the requests. And based upon a risk score, we can block certain requests from creating accounts. Number 3, we are looking at behavioral patterns, a large number of accounts created by the same phone number. There is a reasonable limit there. And once things go past the reasonable limit, we start to block those clients. And since you have token acquired here, we can block them based on IP address as well as an individual client coming with the token. And lastly, if anybody is trying to create a account using stolen credentials, we can block that as well by improving the security posture of the users on your applications and websites. Here's the request flow for ATP and account creation fraud prevention. Very similar to targeted bots. The reason I want to show this diagram here and why this is important is as we started designing bot control and fraud prevention, we recognize that these operators are constantly evolving. So we did 2 things. First, we packaged our configurations in managed rule groups where we are able to innovate and add more rules to those rule groups. And secondly, what we have built is a very complementary architecture in the back end, which is extensible as we add new kind of services and new rules that become automatically available as part of the AMRs. With that, I am going to hand it back to Chris, and we're going to talk about a few real-life scenarios. Thank you.
Thanks, Nitin. So who here is a gamer? Me, I like games, and I hate people who try to keep me from playing games. So in this particular instance, there was an online gaming company. They had a challenge. They were getting hit by denial of service attacks. The denial of service attacks weren't particularly amazing in terms of their complexity, but they were causing them infrastructure impact, making it so users couldn't log in, and they were causing them to lose money. And so we engaged with them. The awesome thing about their scenario was it was fairly quick to identify from their traffic, all right, you have these kinds of DDoS events happening. They're probably largely generated off of scripts that aren't super complicated. So what we're going to do is we're going to enable bot control, and we're going to enable the challenge action. So if you remember back to what Nitin was talking about, what that means is that when a customer is performing an action on the site, or a DDoS agent was performing an action on the site, we would send back, challenge it, they would have to run a script, come back with a proof of work, and then they were allowed to proceed, or we would block those actions. So you can see here, the scripts were executing on those graph at the top. You can see how high they were peaking. And if you look at the graph at the bottom, you can see that the website traffic statistics didn't even move. So the challenge effectively prevented those DDoS attacks and kept the gaming company operating. Another great scenario is around this travel website. So they had a couple challenges. One of them was they operated a lot of websites. So they had a broad footprint, and they were having agents that were targeting their website. So it wasn't just somebody who was trying to cause mayhem and make a website overload. They were trying to accomplish a specific purpose. So the first thing was around trying to consolidate their websites into a smaller number of web ACLs. And so that's around using CloudFront as a controlled front door, and then having a smaller number of web ACLs so it's easier to control. The second thing was just, okay, enable to get breathing space, right? So you have something bad happening, your site isn't working, you need breathing space so that you can figure out what a long-term solution is going to be. So the easiest thing was enabling our common bots and challenge. So that immediately reduced traffic about 50% in their scenario. So they were having, previous to that, super big challenges around their infrastructure. This gave them breathing space. But as they had breathing space, the bots began to evolve. Because they were targeted at this company, there was a motivation behind it. There was a financial motivation. And they were adapting, and they were using automated browsers as opposed to just doing scripts that were hammering the website and getting information from it. And so we worked with them after doing the traffic analysis to suggest that they would go into targeted bots along with some custom rules. And that was able to reduce their traffic another 19% even after it started ramping back up again. So it was a relatively easy thing for them to do, and had great effects both in terms of their operational health, being able to manage more of their security through one place, but also traffic reduction. And the last one was a mobile e-commerce app. So they had threats out of malicious bots. They were doing account takeovers, and with the account takeovers, what that means is that they were having bots who were performing actions as if they were people. So the bots were trying to masquerade as humans. They were going in, they were doing fake reviews, they were trying to extract user information. And the company had their own custom-built solution, which isn't unusual. If your company's been around for a long time, you've probably run into this problem, you've tried to control it. What's pretty clear is that it's a cat and mouse game, and so you have to always be investing in that and always maintaining it. So one of the nice things about AWS WAF is that we take that burden from you. So we implemented account takeover protection with them. It was effective, which is great, but they were getting, actually, let's go back. They were getting an awful lot of requests. They were getting 28 million requests in 5 minutes. It was sort of nutty. And so what was happening is we would mitigate the attack, but then we had to issue an awful lot of challenges and get an awful lot of responses back, which turns out it cost them more money than they were expecting. It was actually a higher rate than we had expected for account takeover protection. So what we did is we engaged with them and had SAs work with them to come up with a different solution. And one of the nice things about AWS WAF and AWS services in general is that they're very composable. There are lots of easy ways that you can do it. So using Amazon Managed Rules, the AMRs, you can just say, I want to block bots and I would like to I would like to have common and targeted, and it will do most of the work for you. In this case, they came up with an optimized solution around running the rule and count mode. Once they saw a tick up in count mode, they knew that there was a spike in account takeover traffic. They switched it over to block, and then they added source IPs to a deny list with a TTL. So it wouldn't execute the IP forever. It would die off over time. As a result, they were able to achieve similar levels of protection with latency, but their cost was, they saved about 99% in terms of that because they were willing to live without latency. So one of the nice things here is we have a composable system. You can make your own rules. You can utilize the logs to be able to accommodate your particular user scenarios. It gives you flexibility, and we can work with you to always try to keep costs reduced. Also, in this particular case, we reduced pricing for that particular action and made it tiered. Because we learn as we make things. So recapping. So determine your best options for acquiring tokens. So as Nitin was saying, it's either going to be that redirect, no code. If you're working on a web browser, that's awesome. If you're using a mobile app, you want to have an SDK. Scope down statements for managing costs. So you want to be applying things in an order. So you do cheap rules first because they're going to execute first. Then you do the more expensive ones down. You try to scope down the endpoints that you're concerned about. Don't worry as much about ones that you don't think are going to be causing a problem for you. Consider rule evaluation, again, probably cheapest to most expensive. Always have count mode on. It doesn't cost you anything, and you're going to be able to get both baselines from what we can do from a DDoS perspective, but you're also going to know a lot of information about how WAF is working for you. And with that, takeaways. Well, we have some easy-to-use solutions here that should help you literally today if you went back and tried to do it. Always try to give yourself breathing space when you're dealing with a DDoS attack or some other kind of attack. So you want to focus on mitigating, then you want to focus on fixing afterwards. And last, don't be afraid to reach out to us to have us help you. We love this work, and we love working with our customers to make it even better. There are some related sessions, so you can use the QR codes. These will help you learn even more about AWS WAF. Thank you very much for coming, and please fill out your surveys. So thank you very much.